Hey guys, today we are going to continue our work with angles and we're going to move on to adjacent and vertical angles. So we're going to first start with adjacent angles. Those are just angles that share a vertex. Remember that a vertex is just the point or where our angle is. So they're angles that share a vertex and a side. So they have to share both. And these are angles that are next to each other. So when we are looking at two angles that are adjacent, they're adjacent angles if they share a vertex and a side, but have no interior points in common. So when we are looking at this example here, AOB, if we look at this angle, I'm going to kind of change out some colors here just so we can see these a little bit better. But if we look at the angle AOB, we're looking at this angle here, and really that's everything in between the two lines. So it's this angle here, and we're looking at angle BOC. So I'm going to change my color, and then we're looking at this one here, BOC. These two angles are adjacent because they are sharing the same vertex back here at O, and also they're sharing this line here, the line OB. They both have that same side. So those two are adjacent angles. Over here, looking at angle AOB, we're looking at this angle, all this in between. So we can kind of shade this. And COD, this time, these angles are not adjacent because even though they share a vertex, right, they do not share a common side. So AOB and COD are not adjacent angles. Now, another thing that we had mentioned that they can't share any interior points. So I'm actually going to erase this for a second and show you what I mean by that. All right, if we're talking about interior points, that would be, for example, if I looked at angle AOC. I'm looking at this angle here, right? So I would shade all of this because that's the angle I'm looking at. And if I was looking at angle BOD, that would come up here and come down and out to D. And these would have points that overlap. This section here where there's both the purple and blue, those would be interior points that would be in common. So again, they share the same vertex O, but they don't share a common side. Really, they have these points in common, they overlap. So those would not be adjacent either. So I'm going to erase this back out. Okay. If we look, let's move down at this. We're going to do some examples together. So it says practice, find the angles that are adjacent below. So it says which angles are adjacent to angle ADB. So first we're going to identify ADB. So I'm coming here. This is the angle that I'm going to be looking at first. I want to find, and remember that's all of this in here makes up that angle. If I want to look for one that is adjacent to ADB, the two easiest to find would be looking just, again, sharing the same vertex and sharing a common side. So BDE would be one. So I'm going to write that as angle BDE. And another one would be over here, ADC. So sharing this whole part here. Those are probably two of my easiest angles. So that was A, D, C. Those are two of the easiest angles to see just because they're the ones that are right next to my original angle, right next to angle ADB. We could choose some other ones as well. We could kind of look at this a little bit bigger instead of just looking at ADE. We could open that up and look at like BDG or BDF or even BDC. Those would all be adjacent angles as well. But like I said, these two are probably the easiest to see, probably the most common that are going to be chosen. If you choose an angle different than what we wrote here, just check with Mrs. Braun or Mrs. Solberg, and we can double check to make sure you've got a correct adjacent angle because there are more than just those two. Okay, so I'm going to clear this off again, and we are going to take a look at the next practice. It says which angles are adjacent to angle GDC. So I am going to look at GDC. So this whole angle here. All right, so to look for some that are adjacent, I want to look at which ones share the same vertex, so D, and that have a common side. So again, probably one of the easiest to see would be right here, and that would be ADC. And then on this side as well, where we have angle EDG. Okay, and then we have another one that we're going to look for. Which angles are adjacent to angle BDE? So we'll erase what we have here and check out this one. All right, so angle BDE. Now we're looking right here. And again, we're really looking at everything inside of here makes up that angle. So the easiest ones to see are going to be the ones that share the same vertex here and the ones that are right next to it. So I can look at angle ADB. And angle EDG. Okay. So we're going to take a look here. It says use information provided to find the value of the angles below. So we're going to be doing some work. We're going to tie in algebra here a little bit. And we are going to use what we just learned about adjacent angles to find some angle measures. The first one says the measure of angle PRS is 80 degrees. What is the value of X? So what they're telling us is PRS, this whole angle here, everything inside here is 80 degrees. So that means this angle, that's 25 degrees, and my angle X is going to add up to 80 degrees. So I'm going to write an equation to help me solve that. 25 plus X equals 80. And remember, when we solve this, we're going to use the same strategies we did in topic 8. We're going to draw our line down the equal sign, and we want to isolate our variable. We want to get X by itself. So I'm going to start by subtracting 25 on both sides. I want to use my inverse operations. That's going to leave me with X on the left, and 80 minus 25 is going to give me 55 on the right. Because if I borrow from my 8, 10 minus 5 is 5, and 7 minus 2 gives me 5. So our missing angle is 55 degrees. So then on our next one, it says the measure of ABC is 100 degrees. So this whole obtuse angle is 100 degrees. So I know that whatever I add with these two angles, I'm going to get 100. So if I look at the two angles I know, I have 2x and 60. So 2x plus 60 equals 100. So again, I'm going to use the same strategy. I'm going to draw my line down my equal sign, and then I'm going to start by subtracting 60 on both sides. When I do that, my positive 60 minus 60, that's going to cancel and leave me with just 2x on the left. And 100 minus 60 gives me 40. Then I'm going to divide both sides by 2. I want to get my x by itself, so I have to divide by 2. That leaves me with x equals 20. 40 divided by 2 is 20, so x equals 20. Okay, so that is just kind of an introduction to adjacent angles. Now we're going to move on to something that honestly I think is a little bit easier. Vertical angles, I think they just tend to be a little easier to work with. They're a little less confusing. So we're going to come onto the back and take a look at our vertical angles. So basically vertical angles, they are a pair of congruent angles. And remember what congruent means. Congruent just means that they have the same measure. So another thing about vertical angles is they are directly across from each other. So if you look up here at this example, vertical angles are formed by two intersecting lines and are opposite each other. So vertical angles are going to have equal measures. That means over here, my angle 1 and angle 3 are vertical angles, and also angles 2 and 4 are vertical angles. So that means that they have the same measure. All right. When we are working with vertical angles, we're going to find the measures. So we're going to practice this a little bit, and I'm going to keep changing colors just so it's kind of easier to see. It says which angle is vertical to angle R. So first I want to look at angle R, which is this right here. I want to look for which angle is directly across from that. And the cool thing is the angle actually kind of points to its vertical angle. So this little pointing right here, it points us right over here to angle S, which is our vertical angle. So the angle is vertical to angle R is just angle S. So let's take a look at our next one. Which angle is vertical to angle M? So again, we're going to locate angle M, which is right here. And again, it's pointing us right to where we need to go. The angle opposite across from it is angle P. So angle P is the angle vertical to angle M. And then our last one here is asking us which angle is vertical to angle N. So I'm going to look for angle N. That's right here. I'm just going to kind of highlight that to show where it is. And again, it's pointing across to angle O. So angle O is vertical to angle N. Okay, see, I told you these are a little bit easier to work with. So as we keep looking, we're going to do a little more practice. We're going to use, again, some algebra to figure out these missing values. So when we want to solve for y here, we have 11y minus 36 on this side, and we have 63 degrees over here. So if I look, I can see that these are vertical angles because they're across from each other. Okay. And I know that my vertical angles are equal, they're equivalent. So what I can do is really just put my equal sign right there in the middle. So 11y minus 36 equals 63. I'm going to solve just like I would any normal equation. I'm going to draw my line down my equal sign, and I'm going to isolate my variable. I'm going to get my y by itself. So in order to get my y by itself, I need to start to undo the problem. So to get rid of my minus 36, I'm going to add 36 on both sides. When I do that, I'm left with 11y on the left, and 63 plus 36 gives me 99. Then I need to get rid of my 11, and 11y means 11 times y, so I use division to undo that, and 99 divided by 11 leaves me with just y equals 9. So y equals 9 is my solution. Okay, so let's take a look at our last example. So what we have here, we want to find the value of x. So I have 5x here, and my vertical angle is the one across here, but I don't have a value of that yet. What I do know is the value of this angle right here. And I also have something else that's really important here. I have this, let's change color a little bit. I have this box right here telling me that this whole angle, UYX, is 90 degrees, right? That's a right angle, it's equal to 90 degrees. So what that's going to tell me is whatever I have here, this angle that I'm looking for, this question mark, plus 40 is going to be equal to 90. So I can just solve like I would any equation here. If I subtract 40 on both sides, I'm told that this missing angle is 50 degrees. So now I know that this angle up here is 50 degrees, and I know that this is 5x. So then I can go ahead and set up my equation so that 5x equals 50. And then I would just solve like normal, line down the equal sign, and then to get rid of my 5, since it's 5x, it's 5 times x, so I'm going to divide both sides by 5. When I do that, I'm left with just x on the left, and 50 divided by 5 is 10. So x equals 10. Okay, so those are our notes for both adjacent and vertical angles. We're going to do some activities to practice. You're going to have an independent practice where you're going to have a little maze activity that you're going to solve some problems. And then we're going to do a bingo game to review what we've learned about supplementary angles, complementary angles, adjacent and vertical angles. So we're going to do some practice. If you have any questions about any of these notes, feel free to go back, look through the information, or ask Mrs. Brown or Mrs. Solberg for help.